Hello, and welcome to CAWST's first online training about Biosand filters. My name is Sandy Davis, and I am going to be presenting this online training. And with me are my colleagues Melinda Foran, she's going to be monitoring the chat box, and Olivier Mills, who is also helping on the technical side. So I would like to welcome you to the Biosand filter training. We're going to be talking about Biosand filter designs and molds, filtration sand, um, follow-up tools that you can be using, and also costing tools. So we're going to move through these four sections, starting with different Biosand filter designs and molds. So CAWST has had several different versions of Biosand filters. The first being version 8 back in about 2001. And now we've progressed through. As we get new research, we periodically redesign the filter, and we're currently recommending version 10 filters. So there are a few differences. They are essentially the same in function. Version 8 filters were originally designed with quite thick concrete walls, and this allowed for a 1/2-inch PVC pipe to be put inside of the wall. Around 2004, we moved to version 9 filters, and these had significantly thinner walls, which meant that they were easier and lighter and cheaper to produce. Because the walls were thinner, they now incorporated a 3/8 of an inch plastic tubing that was a flexible PVC pipe, or flexible polyvinyl. When we started getting some research in regarding how long the water stays inside the sand of the filter and how that affects the water treatment, we looked at our design and recalculated some of the parameters and some of the dimensions and came up with a version 10 design around 2008. And this is the model that, based on research, we believe gives the best possible water treatment, and this is what we're currently recommending. So between the version 9 and 10, there are a few differences. The height of the nose moved up, and this was to accommodate more sand inside the filter. So the depth of sand is greater in version 10, and the reservoir, the top of the filter where you pour in the water, is smaller. And so because of this, you have less pressure, less head from the water in the reservoir, pushing the water down through more sand. And so you end up with a slower flow rate through the filter. So some of the specific changes are in version 10, the reservoir fill volume is about 12 liters, and the flow rate is about 0.4 liters per minute maximum, or 400 milliliters per minute, whereas with previous versions of the filter it was 600 milliliters per minute, or 0.6 liters per minute. And again, the depth of sand is a little bit higher in version 10. With your version 10 molds, last year we brought out some instructions for how to build your steel molds for these filters. And with version 10, there's two different options. So the first one is with a ledge or lip, and then the second one is no ledge or lip. And I'm going to just explain what that means. So the version 10 with ledge is similar inside to the version 8 and 9, where you have inside that filter, in the inside wall, you have a ledge or a lip where you can sit a diffuser plate. So this is at the bottom of your reservoir, and that's what you pour the water onto so that the water doesn't disturb the sand. With these filters, you can use the plate, which is a simple acrylic or sheet metal, for example, plate with holes in it, or you can use what we call a diffuser box, and that box has walls and it can hang from the top of the filter. For the version 10 with no ledge, you have to use a diffuser box because that ledge or that lip is missing, and so there's nowhere for you to sit a diffuser plate. The advantage of using this mold is that because it doesn't incorporate that lip, it's easier and less complex to make, and it's also cheaper. So if you're looking at building new molds, and you know that you're going to be using only diffuser boxes, this would be a really good option. In terms of effectiveness of the filters, these two are identical. And if you are using earlier versions, say 8 or 9, they're adequate. You don't need to be worried that, that they're not working or that you need to upgrade to version 10. While we recommend version 10, we believe that these are giving the best water treatment results. Version 8 and 9 are great filters. They're still treating your water really well. It's just that we've incorporated some new research into the design of the version 10. So if you're looking at building new molds, or if you'd like to upgrade to version 10, the version 10 with a ledge or no ledge are really good alternatives. There are some other types of biosand filters that require either a different type of mold or no molds at all. For example, this is a sheet metal mold. So it still makes a concrete filter, but it's a lighter sheet metal mold that you can take with you. It's easy to transport and that kind of thing. It rolls up. One of the drawbacks in comparison to a steel mold is that it may not last as long. So steel molds will last for years and hundreds of filters, whereas these, if you're doing a smaller project or in a remote region, this might be an option for you. Another one is a round version of the steel mold. Some organizations are using these to produce round concrete filters. This is an example of a filter that does not require any mold. It's a concrete pipe, precast concrete pipe that's cut to size and cast into a base. And then in Pakistan, they implement these. They attach a metal spout to them, and they use these as biosand filters. Another type of filter that does not require mold or plastic filters. So commercially available are hydrate filters, and they'll ship these filter bodies internationally. Some organizations, such as ENFO in Nepal, actually construct their own filters out of plastic containers that they find in the local market. So something to keep in mind about some of these alternate designs of filters is that CAWST cannot guarantee any certain level of treatment efficiency or performance of these filters. So the design that has been researched and that we have experience with, and universities have researched, and we get those results, is the CAWST design, the standard concrete square filters. So while you may want to experiment and look into some of these other models, and they may work really well, CAWST doesn't have as much experience or in-depth knowledge about the parameters and the efficiencies of these other filters. So I would encourage you to contact CAWST if you're considering other designs, and we can give you some tips and advice about some of the important parameters that need to be kept in mind when you're looking at alternate designs. So on CAWST's website, which you will get the link to at the end of this presentation, we have several resources that can help you build molds, such as our mold construction guidelines and a picture book that will help you go through with your welder and actually showing you what the different components of the mold are as you're welding it together and cutting it out. That can be really helpful. So lots of resources there if you search for mold on the CAWST resources website. We're going to move on to talking about sand. So the reason sand is so important, why CAWST put so much emphasis onto selecting and preparing good filtration sand, is that the flow rate of the water through the filter is what impacts pathogen removal. It's what determines the treatment efficiency of the filter. And the flow rate is directly determined by the type of sand that you put inside your filter. If the flow rate is too high, there's less opportunity for the pathogens to be removed from the water as it's flowing through those top layers of sand. Also, shear forces can dislodge the pathogens, so they can actually be knocked off when they stick to the sand grains, and that's how they're removed from the water. If the water's flowing through too fast, it can actually knock those pathogens off of the sand, and they'll get back into the flow of water. If the flow rate is too low, it won't necessarily impact treatment negatively, but people may not like it. They may not use the filter if it takes too long to fill up their water container. So the sand is what determines this flow rate and provides opportunities for the pathogens to be removed from the water. So selecting sand, sand comes from many, many places. One place is from a sand quarry or a sand pit, a rock crushing operation where they're mining out chunks of rock and crushing it up into different sizes. Beach sand, desert sand, and sand along rivers is a really common place to get sand for construction activities. So I have another poll for you, and some of you, if you have taken a CAWST course, will probably know the answer. So what is the best place to get your filtration sand for biosand filters, for using inside the filter? If you will just take a few seconds, you can input your ideas there. If you're not sure, you can take a guess. We'll give you a few more seconds. And a few people are commenting rather than clicking on the poll. Crushed rock, sand from a quarry. Okay, I'm going to close the poll. So here are the results. About half of you say crushed rock from a rock mining operation. Crushed rock is the right answer. That's great. Sand from a quarry or sand pit's probably your second best bet. So why do we say that? What are we looking for in our filtration sand? Oops. So the first thing we're looking for is lots of different grain sizes. If you take a handful of sand, there's going to be some very fine dust ranging up to quite coarse pieces of sand, large pieces. CAWST has a recommended range for the type of sand grains that you want, and it should be from very fine up to 0.7 millimeters. So you're going to screen your sand through a 0.7 millimeter screen and then use what goes through that screen. The second criteria that we're looking for is that it's clean. No organic matter in the sand is one of the most important points. So sand that you get from a river, sometimes from a sand pit or a sand quarry, often has things like leaves, sticks, fibers in it. And the problem with this organic matter is when it's down inside your filter, it acts as a food source for microbes, and you'll actually start growing a community of microbes inside your filter. What happens is when this is deeper in your filter and there's no oxygen, it becomes an anaerobic, oxygen-free environment, and those microbes start to smell. So basically, we don't want a breeding ground for microbes. We're trying to get rid of all the microbes from the water. So no organic matter, that's the main reason we want it to be clean. No salt. Beach sand is usually quite salty, and the water coming out of the filter will have a salty taste. Obviously no harmful chemicals in the sand, and no animal or human waste. River sand is often contaminated from fish waste, animal waste, human waste, people who are defecating in the river, and that's obviously something that we don't want to be putting into our biosand filter. The third criteria is not too much of the very fine dust, because you're going to have to wash that out. And you don't want to have to spend too much time washing your sand. If there's too much dust or powder in the sand, it's going to clog your filter up and you're going to have a very slow flow rate. So we say that looking for crushed rock and spending a little bit more money on it is worth it, because you're getting that really clean, good quality filtration sand that's going to give you good water treatment. So if you found a supplier of crushed rock, now what do you do? Well, there's a lot of different types of crushed rock. So how do you know if this is going to make good filtration sand? You do what's called a grain size analysis test to assess the sand. When you do a grain size analysis test, CAWST provides instructions for this test. It tells you these different parameters. The most important two that we're looking for is what is effective size and what is the uniformity coefficient. So we have recommended ranges for your filtration sand of what these should calculate out to be, and I'm just going to talk a little bit more now about what these are. The effective size of the sand is talking about the sand grain diameter. So within your range of sand, 10% of the grains are smaller than this diameter. So 90% are bigger. For example, if this picture represents your sample of sand, there's large grains, small grains, some fine dust. If you separated all those grains out into their sizes, and you have maybe, say, this size where the arrow is pointing, 10% are smaller than that size. So this is what we call effective size, or D10. So CAWST recommends that your effective size is 0.15 to 0.2 millimeters. So doing a grain size analysis will help you determine what your effective size is. And why is this important? This basically affects the flow rate. So the smaller your D10, if it's below 0.15, you're going to have a very slow flow rate in the filter. So doing this quick grain size analysis can give you a quick picture about whether this has way too much small stuff in it, small grains, and whether it's not going to be effective, it's just going to clog up your filter. Or alternately, if there's too much coarse, big stuff, and it's going to be, your flow rate's going to be too fast. The second parameter is uniformity coefficient, and this tells you how wide the range of grain size is within your sample. So if you have a low uniformity coefficient, all the grains are similar sizes. There's not much variation. They're all fine or they're all coarse. If you have a high uniformity coefficient, you have a good range of sizes. So for example, if you have all coarse pebbles, you have a very low uniformity coefficient. With a high uniformity coefficient, all the small, finer pieces fit in between the bigger pieces, and you get higher packing in your sand. So this is how the uniformity coefficient affects your flow rate. So CAWST recommends that you have a uniformity coefficient of 1.5 to 2.5. So now I'm going to talk about how you calculate these things. This is what we call our mini sieve set. So CAWST sells these sets for $75 plus shipping. We also have instructions on how to make them. So you have a series of dishes, and they all have different size screens in them. You put a sample of your sand that you're looking at purchasing into the top, and you shake it down through all of the different levels of screens. And before I go on, I'm going to do a quick poll and just ask you if you have ever done one of these before. So you can just vote with your answers. There may be different reasons you've done these tests. You can do them in the field when you're looking for sand. You can actually do them once you've gotten a truckload of sand to assess what you've already bought. So if you can just pop in your answers into that poll that should be up on your screen. I'll give you just a few more seconds. Okay, and I'm going to close the poll. So about half of you have not done this before, and the other half have for various reasons, either to find filtration sand, test it, or for other reasons, maybe geotechnical engineering. This is a standard test that you do on sands. Great, okay. So this picture that I've got up is actually when we were out in northern Thailand with two organizations doing grain size analyses to try to find good filtration sand. They'd had trouble. So we went around to different sand suppliers, found piles of sand, picked it up, felt it in our hands, thought, yeah, that's a possibility, and then ran it through the mini sieve set. So the picture on the bottom there shows the paper graphing method of calculating the parameters. So there are the 3 different bags of sand that we got from different suppliers with their results. So that's how you would use it possibly in the field if you're looking for good filtration sand. So the paper method up until this year was the only way that you could do this calculation. So you you do your sieve set, you measure how much sand is retained on each of those sieves, pour it into that graduated cylinder that you see in the photos, and then you plot that on a chart and you do your calculations by hand for your effective size and your uniformity coefficient. It works, it's great, it's easy to take out in the field with you, and we have instructions on how to do that. Since this year, Samaritan's Purse developed a spreadsheet that does all that work for you, which is fantastic. They shared it with CAWST, and we worked together to refine it and get it out globally in an easy-to-use format. So I'd like to show you that. And one of the files, if you downloaded the pre-reading materials, is that that folder, that Excel file. So I'm going to pull it up. So basically, this is you still have to run the sample of sand through the mini sieves, and then you pour it into the graduated cylinder and measure how much you've got on each sieve. Except instead of having to calculate out your numbers, all you do is you pop them in here. So you have 12 milliliters on the first screen, 50 on the second screen, 69, 78, so you pop your numbers in there. On the data to enter tab, you come over to the summary table tab. No graphing, no calculating. You can see straight away. Sorry, let me just get this so you can see the whole line. You can see straight away whether it has passed uniformity coefficient and effective size. So that's a really simple way to put in those numbers. This spreadsheet you can also use to track your sand. So you can try different sand sources, you can track your sand that you're getting in on an ongoing basis. The interesting thing about this spreadsheet is you can also put in your flow rate. And so when you've used the sand, installed a trial filter, test the flow rate with the sand in it, and see what you get. If it's in the acceptable range, so if you're using a version 10 filter and you're getting a flow rate of less than 400 milliliters per minute, pop it in there. It'll tell you if that is a good result. And you can start to look at, well, if my effective size is really low, how does that affect my flow rate? Or if my uniformity coefficient varies, how does that affect my flow rate? This is something that's not very well understood by researchers or by CAWST. Based on all the research and experience we have our recommended ranges, but they do interact together in different ways. So what we are suggesting is that if you're using this spreadsheet and monitoring your sand results and your flow rate results, if you can send us your results, so just send us the few lines of data, or send us your spreadsheet, and we can start a database and tracking how these things interact and how your sand really does affect that flow rate and the treatment in your filter. So if you're using it to track your flow rate as well, back on the data to enter tab, you would put your flow rate in here. There's a column for flow rate. And then because different people are using different versions, you would also put in your target flow rate. So if you're using a version 8 filter, your target flow rate is 600 milliliters per minute. And then you might get a flow rate of 550. And then it will show in the next tab whether or not that's acceptable. Great. So if there's any questions, just pop them into the chat box. I'm going to try and get to the questions if we can. If there's questions that we can't get to during this presentation, we will follow up with an email and or post them online. All right. So all of these resources, including this SAND spreadsheet, are downloadable from our website, and I will post the website link at the end of the presentation, and you will also get it in follow-up emails. Okay, so let's move on. That concludes our sand section. Now we've got some new tools and information that you can use for user follow-up. So end user education. Um, we know from various development initiatives and projects that both overseas and in North America, everywhere around the world, learning and adopting new behaviors, it requires a lot of time, a lot of repetition. We are creatures of habit, and it does require reminders. As you know, if you've done your projects, it's really difficult to say something once and everybody all of a sudden does it. So end user education is a vital part of a filter project, and that can be done at community gatherings and meetings, information sessions, in the home when the filter is being installed, and during follow-up visits where you come back to check on the filter, ask if the family have questions, and see how things are going. So some of the tools that CAWST has that you may not be aware of is brochures, different puzzles, posters, and monitoring forms. The brochures that we have are ones that are intended to be left with the user, the family. They're available in 5 different regional styles with different pictures. And there's a spot where you can either enter your organization's name or put a sticker on there, because it's really important that if people have questions or if something breaks or their filter clogs up, that they know who they can contact. So this is an example of one that you can use in Africa. These are available as Microsoft Publisher files as well as PDF files. So if you would like to modify these, you can take images from it, you can translate it into the local language. That's a really good idea. These publisher files are available for you. And again, they're available in a Latin American style, South Asia, Southeast Asia, Africa. So we have them in several different regions. You can select the one for where you're working. Another thing that CAWST has available is posters. We have big posters that you can print out in, say, A1 size or larger of a Biosand filter. We have them in version 9 and version 10. And also puzzles. And these are, again, big poster sizes. You can cut them up. And these are great for using in community education sessions, for teaching and reminding people about how the filter works, pointing to the different parts of it. You can get people to come up and put the parts of the filter in the right order, and explaining how the filter works and what each part does. We also have some poster sets available. The top one here is our water hygiene and sanitation presentation set. These come with images, again, in 5 or 6 different regional styles. And they also have text on the back. So this is something that you can use in a community presentation, in follow-up visits to households. You can give this set of posters to your health promoters or whoever's doing your household visits. And they've got text on the backs to help them explain what each picture means. And they go through all sorts of different topics such as hand washing, why you should use a latrine, different types of household water treatment and how you use them. So those are the poster sets that we have. We also have a series of fact sheets on different household water treatment technologies. So the Biosand filter is one that's shown there. We also have them for ceramic filters, for chlorine, for boiling, for settling, and they come either as standalone, just the fact sheets, or as a poster set with a picture of the treatment method on one side and the simplified fact sheet on the back side. So again, these are all downloadable from our new website. They hopefully be easy for you to find up there. I'll send out the links in the final presentation as well. I've got a quick poll just to see when your organization is doing user education. So do you do it at community events or do you do it at households? And you can put in different answers to this one. So just pop your answers in there about at what times do you do user education for your filter projects. We'll give you a few more seconds. All right, and I'm going to close the poll. Oh, a few more people, votes coming in. All right, 5 more seconds. All right, I'm going to close the poll. So about half are doing it at community events altogether, as well as perhaps during the installation in the filter. And almost half are doing it at a different time or as follow-up visits. So that's great. So that's hooking into that fact that people need reminders and follow-up and like to be connected in case they have problems or issues in the future, be reminded about proper use. So that's great. CAWST believes that follow-up education and follow-up visits in the period of about a year after installing the filter is critical to sustained use of the filters. So that's great to see. Thank you. And at this point, I'm going to move on to monitoring forms. But if your organization does use different types of educational materials, for example, maybe you put a sticker on the side of the filter or you leave something else with the user, can you just enter that into the chat box to share with everybody? So as you're entering into your different, into your chat, if you use any other tools for user education, I'm going to move on to monitoring. Some of the things that we have available for monitoring in terms of forms that it's important to monitor are not only that user follow-up side, but also your filter production, so that you know your quality of filter production and how you can improve that, your sand preparation, and your correct installation and setup when you're installing the filters. So we have forms available for all these different types of monitoring. They're available in Word documents as well as PDFs. Again, you can translate them, you can modify them to collect the information that you want to collect. So 2 important things that you should be considering when you're using your forms and designing your forms is that they should be modified to your local context and language. If the people that are working for your organization who are doing the monitoring don't have strong English skills, it's a really good idea to have those translated, obviously. Literacy level is another big consideration. We have some forms that are very text heavy, such as the one that you're seeing on the right of your screen. It's a series of questions. People have to be pretty good at reading and writing to answer those questions. Sometimes if you're using villagers for doing monitoring, or if you have community health promoters who have a lower literacy level, you may want to use a more illustrated follow-up monitoring form. For example, the one on the left on your screen. So it has a lot more pictures. People can almost understand, if they know the form, they can understand what they're looking for just by looking at the pictures. They don't have to have really high literacy skills. And then it's just a check mark if it's correct, or an X if it's not correct in the home that they're visiting. So after you use your monitoring forms, the question is, what do you do with that? It's not useful to monitor if you're not using that data. So CAWST does have some monitoring manuals and other information on how to organize and collect that data and review it. So usually the project manager is collecting all those monitoring forms. And then how you tally them up or put them into graphs to track your results is the next really important step of monitoring. So if you go on the CAWST website and search monitoring, if this is something you're interested in, it's something that we do have information on. Okay. I had one question about monitoring water quality. It's not something that CAWST deems particularly critical in biosand filter projects doing chemical testing or biological testing of the water. We have 8 recommended parameters, which are shown there on the illustrated form. which are what we call our key operating parameters or our key filter monitoring points. Based on research and what we know from the filter's operation, if these 8 things, such as you have a correct standing water depth above your sand, you have the correct flow rate, the filter's used every day, if these 8 things are met, then you should have good water quality coming out of your filter. Water quality can be complex and expensive to monitor. So if it's something that your donors require, it's something you can do, but it's not something that CAWST recommends as a critical component of your monitoring. Great, so our last section is about costing. And CAWST has two different types of tools that you can use. One is a Word document of costing tables, and one is a spreadsheet. The spreadsheet is probably more user-friendly if you're trying to track costs and really make a very context-specific budget for yourself. So I'm going to show you examples of both of those. Both of these tools include both hard costs, so your materials for constructing your filters, as well as the soft costs, so including things like that user education and follow-up. So when people talk about the cost of the filter, you hear a lot of different prices about, oh, our filters cost $10, our filters cost $110. So usually what that reflects is what people are including in that cost. So if you're only including the materials to construct the filter itself and possibly install it, that price is going to be a lot lower. So I'd like to poll, for those of you who are implementing, how much does your organization say your filters cost per filter? Just give us an idea of how people are quoting these costs. And if you don't know or you're not implementing, just hit the I don't know button. And we'll give you a few more seconds. Okay, I'm going to close the poll. So a few people actually have filters that cost less than $20. The majority are in the $20 to $75 range, and then some are more than $75. So for those of you who say it's who gave a cost, can you also answer this poll? Does that include your soft costs, such as user education, your follow-up visits? And again, soft costs, what we mean by that can really vary from organization to organization. It may include transportation, installation, or you may interpret that just to mean user education, printing materials for user education. Okay, I'll give you just 5 more seconds to poll. Okay, thanks. So some people are including those costs and some people are not. Great, thank you. Again, administrative costs, absolutely, it completely depends on how you're calculating that cost. You can also take the entire cost of your project, so you can include your overhead, you can include everything that goes into your project, divide that by the number of filters that you've produced as part of that project. That would give you the most accurate reflection of how much it truly costs you to produce a filter, and to install it, to educate it, to get people using it sustainably. If you're just looking at how much it costs to produce the filter itself, it's a really different thing. So this is one of those confusing terms, I guess, that when it's like comparing apples to oranges when people talk about how much their Biosand filters cost. Okay, let me move on to the next slide. So again, these are some of the things: monitoring, filter installation, sand and gravel. Okay, and we have one more comment that they're including follow-up training and their cost is over $75 per filter from Helen Bond. Thank you. So I want to share our spreadsheet with you. If you haven't seen this, it's a great tool that you can use either when setting up your project or to track your costs ongoing as they're changing and as you're getting your as your material costs change. So this is our spreadsheet for budget tracking for a filter project. And what we've done is gone through and put in a bunch of typical materials. We're on the construction and installation tab in this spreadsheet. So now we've got different, how much sand do you use per filter, how much gravel, how much of, all these different things. You need soap to clean it out. You need to paint the outside of it if you're painting them, that kind of thing. Dollars to $20. You can see how much that affects the price of your filter or in your filter. Similarly, just for constructing the filter. And then to include the soft costs, we've also got tabs for transportation, education, and follow-up. And here we've included 3 follow-up visits. You may do more or less, but it includes things like your vehicle costs, your education costs, printing costs, labor costs. So these will combine on the last tab to give changes in costs are having an effect on your total project cost or your total filter cost. Great. Well, that brings us to the end of the presentation itself. I would like to thank you for joining. We're at the end of our time. And we're going to remain on the line for about 15 more minutes. If you have questions, hopefully you can still hear me. Perhaps I've gone offline. Okay, I think I'm back online. Hi again. Sorry about that. I think I had an internet issue. Great. Okay. Well, if you do have questions, feel free to stay on the line. We'll be here to chat if you have to go. Thank you very much for joining us. And here's the link to our resources website. So thank you very much. And please feel free to email us. I get the emails at resources@cawst.org. And that's been fantastic. Thank you very much. Please fill out our evaluation. This is our first training and online. We've had a few technical difficulties. So if you give us our feedback on the content and the flow of the organization, there's also a question about technical. If you had any technical difficulties, we would really appreciate that. So thank you very, very much. Bye. Leaving the truck here until tomorrow to get work done, so I'll pick her
Hi, everyone. This is Melinda Foran. I'm the Director of Education Program Development at CAWST, and I'm just joining Sandy on the line to help with any questions that those of you that are still on might have. I know I've been answering a few in the text box and frantically typing to try and answer all of your questions, but I just want to assure you that we are going to be following up individually with those of you that had questions that maybe we weren't able to answer. Um, so let me look. I'm going to start just going through the chat box um,
Thanks.
and seeing if there are some. Oh, Sandy, are you there?
Hi, I am. Thanks for coming online.
Yeah, no problem. um, Bruce, your question about is there a way to download the webinar on a memory stick? There will be, Olivier will be helping to get an online version that we can provide to you to put on a memory stick. So we're happy to do that. And like we said, it's going to be up online on the GoToTraining website so that you could stream it as well. But we know that's quite difficult. Yeah, so you'll be able to download the video file and save it on a USB. It'll be available tomorrow. Thanks, Bruce. Ah, Richard, glad you were able to join. I know you had lots of questions, and hopefully we'll be able to connect you with Tal Woolsey as well, who's the International Technical Advisor for Uganda. But I'm glad you were able to connect and join with us. Thanks. Judy, I can see that you have your hand up. If you want to type a question in the chat box, I'd be more than happy to answer that for you. Santosh as well. So please just go ahead and type something in the chat box and we'll try and address it.
And I have a question here from Forrest Candall about the molds with no ledge, the version 10 no ledge molds. How are you building diffusers for these filters? Basically, what we recommend is a sheet metal diffuser. Um, so it's actually constructed out of sheet metal, which you can often find somebody locally who is a sheet metal worker, and you bend it up into a box. And so the bottom of the box has holes in it, and then it has a lip on the top, and it hangs from the top of the filter. So instead of sitting on that ledge, it has walls and it hangs from the top of the filter. So if you download our construction manual, there are actually instructions in there on how to build the diffusers, both plates and boxes. So you should find instructions in there.
Sure. We know some of you have been joined a little bit late. So again, watching that video, you'll be able to see the first part of the webinar for the pieces that you missed. So Stephanie had a question about have you tried bucket diffusers as a substitute for the sheet metal baskets? What are the pros and cons? Especially with the round molds that Sandy talked about, it is pretty common to be able to find a plastic bucket that you can use that will sit just inside and hang, similar to the diffuser box that Sandy was describing. In terms of pros and cons, durability, so looking at both options, one might be more durable than another. Ease of construction with those baskets, the sheet metal baskets, they are challenging, and it's challenging to work with someone to be able to put them together really nicely to make them long lasting. So a plastic bucket with the right size holes drilled into it is certainly a lot easier to construct. Thanks, Stephanie.
There was also a question about cold climates and how well the Biosand filter works in cold climates, such as the northern parts of mountainous areas in Peru, for example. And Derek Baker, one of our founders and volunteers, has commented on some input on that. And he says that Sandy Hart with DESEA works in the Andes of Peru, so up to maybe 123,000 feet, and he's installed about 165 filters up there out of 12-inch PVC pipe. and he's not reported any difficulties due to cold temperatures. They're also often sometimes used in Canada. David Manns, who developed the filter originally, has sold some of his plastic filters in Canada and claims they work well. So they obviously won't function while they're frozen if they do freeze, if the water inside freezes, but they will start again once they thaw out. So the biolayer that forms in the top of the sand will take longer to form. Normally we say up to about a month in warm climates, so it may take longer to initially form, and that biolayer is what boosts the treatment efficiency up into the 90%. So initially that growth period will take longer, and the filters will probably be a bit slower. The flow rates will be a bit slower in cold weather, because cold water is a bit more viscous. So Derek says he has read that in cold temperatures they could flow as much as at half the flow rate of what they would at 25 degrees. But that wouldn't necessarily impact the treatment of the filter. So as long as you're not consistently freezing and have a solid block of ice, they have been shown to work in cold climates as well.
And Donald, I know I typed to you as well that we work with a client in Afghanistan, Tier Fund, that has also worked in a lot of colder mountainous climates where the temperatures are getting down quite low. And they've done some water quality testing and some small evaluations of those projects, and they do see a reduction in the filter working, again, for the same reasons that Sandy mentioned. You're not the biolayer isn't going to form as strongly in the cold water, but you still see treatment and improvement in the quality of the water.
Okay, great. We're just running out of time, so I'm going to close. Judy, I'm going to connect you, if you haven't already, with our technical advisor in Haiti. You had just a comment about your project that sort of petered out in Haiti, but we have some contacts and some maybe our technical advisor could be of some help to you there, so I'll connect you. And same with some of the other ones. Santosh, you had a question about how the filters are constructed with the sand inside the filter, so we can definitely follow up with you. And if there are any other questions that we haven't got to, I apologize, and we will definitely be following up one-on-one. So as we said, we're going to um, be posting the video recording and my presentation on our webpage by tomorrow, and you will all be getting the link to that. So feel free to watch it, to share, to pick up bits that you missed, and get in touch. And you can get in touch with myself. The link will be in the emails that you get. Also, we will connect you with your regional technical advisors who can give you really good technical support and connect you with other implementers in your region. So keep your eye out for the next CAWST online training, and we'll use your feedback to make it even better next time. So thank you very much, and have a great rest of your afternoon or night, wherever you are. And we look forward to seeing you online next time.